Welcome to our lesson on the law of sines. In this lesson, we are going to be using the law of sines to solve problems, and we're also going to use the law of sines to help us to determine how many solutions a triangle has, whether it has no solutions, one or two solutions. So we're going to start out by talking about the area of triangles, and we know how to find the area of a triangle. The formula for the area of a triangle is 1/2 the base times the height. But what if we don't know the height? Is there another way that we can calculate the area of the triangle? And as it turns out, we can calculate the area of the triangle using some of our trig ratios that we've been working on. So we have a triangle here, ABC, and its area is 1/2 the base times the height. In this example, the base is C, and then we called the height H. Remember, the height is always the perpendicular distance to the base, from the base to the opposite side or the opposite vertex. And one of the things that we know how to do now from trigonometry is we can find a value for h in terms of trig ratio for one of the angles. For example, I could take the sine of angle A, and that would be the opposite over the hypotenuse, right? Sine is opposite over hypotenuse. So the opposite side is h, the hypotenuse is b. So this is a true statement based on our trig function and the definition of the sine of an angle. If we want to solve that for h, we would multiply both sides by b. So I could just take each of these times b on both sides, and then my b's would cancel on the right, and so h would be b times the sine of a. Well, now I can take that and just substitute it back into that formula. I'm going to take this b times the sine of a and plug it right in here for h. Okay, so I have 1/2 c times h. H is b sine a. And then I'm going to write these alphabetically. Since b comes before c in the alphabet, that's the way I want to write it. And there's a formula for the area of the triangle when I don't know the height. I would need to know this angle A, and I would need to know the two sides that are on either side of angle A. One thing to notice is triangle ABC is not a right triangle. So this works for any triangle. It doesn't have to be a right triangle for this to work. Well, it turns out we can have this be true for any of these three angles in the triangle. So the first one that we just discovered was the area is 1/2 BC sine A. Well, what about if we're at angle B? Well, that one turns out to be 1/2 AC sine B. And what if we're up here at angle C? That one turns out to be 1/2 A times B times the sine of C. So it's whatever the two sides are that make up the angle. If you multiply those together and take half of that product and multiply it by the sine of the angle between the two sides, that gives you the area of the triangle. Well, all of these are measuring the exact same thing. They all measure the area of that triangle. So we're going to get the exact same value no matter which one of those formulas we use. So what happens if we set them equal to each other? Well, if I set those equal, I have this statement, and then I can go ahead, divide each of these terms by 1/2 ABC. So if I do that, if I divide by 1/2 ABC for all three of those statements, here's what I end up with. Now this is kind of cool. So the 1/2 cancels, and this one B and C are going to cancel. So B and C are gone, so I'm going to have the sine of A over A. Over here on this side, the 1/2 cancels, the A and the C are gone. There's A, there's C, so I have the sine of B over B. And on the right-hand side, you see the pattern. A and B are gone. I end up with a sine of C over C. So this is called the law of sines. It says the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Well, this law of sines is very useful to help us solve triangles. So let's go ahead and find out how we can use that. First of all, let's find out how to find the area of a triangle using those formulas that we just came up with. So in this triangle, we know the side opposite angle A, so that's little a. So A is 5, little c is 6, and angle B is 112. Well, it looks like we have enough information for our area formula. So we can use the area formula. That's 1/2 A times C times the sine of B. So that'll be 1/2 5 times 6 times the sine of 112. And if we punch that in our calculator, it's approximately equal to 13.9. Let's go ahead and learn how to solve a triangle. Here's an example where we have two angles are given and a side opposite one of the angles. Well, we can easily calculate angle B, right? We know that those three angles have to add to 180. So if we take 180 minus the sum of 45 and 55, that will give us what angle B is. Well, 45 and 55, that's 100 degrees. And if we take 180 minus 100, that gives us 80 degrees for angle B. Well, let's go ahead and try to find side A then. We know angle A, so we can use the law of sines. We can say the sine of 45 over A is equal to the sine of C over C. So sine of C is 55 degrees divided by its side, which is 12. Now, if we're going to solve this, what we need to do to solve it is we're going to go ahead and cross multiply. So let me just show that to you. We're going to get 12 times the sine of 45 is equal to A times the sine of 55, right? So when I multiply these two, set them equal to the multiplication of those two. And then I need to get A by itself. So I need to divide by the sine of 55. And whatever I do on one side, I have to do on the other. I'm only going to show this to you on one problem here, and it's going to be the same every time. So then my sine of 55s will cross out, right? These cross out, and I'm left with A, which is what I'm trying to solve for. So I get A is equal to 12 times the sine of 45 divided by the sine of 55. So then if I multiply that out and divide it on my calculator, I end up with side A is about 10.4 units. So now I want to go ahead and find the opposite side B. I found side A, I need side B. So I'm going to do the sine of B over B equals the sine of A over A, or excuse me, sine of C over C. And so the sine of B, angle B, we found out was equal to 80. So we're going to do the sine of 80 over B is equal to the sine of 55 over 12. Cross multiplying, we get 12 sine of B, or excuse me, 12 times the sine of 80 is equal to B times the sine of 55. So 12 sine of 80 divided by sine 55, and that gives us approximate value of B is equal to 14.4 units. So here is how you're going to figure out how many solutions a triangle has. So I'll walk through this with you here. Two sides here. If A is an acute angle, so if it's less than 90, we're on this side. If we get a right or obtuse angle, so if it's 90 or more, we're going to be over here on the right side. So let me just walk you through the acute angle scenarios. So if A is an acute angle, all of these have angle A as being less than 90. And then we have a couple of other things. So if B sine of A turns out to be bigger than side A, remember B sine of A was actually this height, right? So if that value is bigger than side A, you can't make a triangle. A has to be bigger, so then there's no solution. If we have B sine of A equal to A, that's just fine. We have a right triangle when that happens, and we get one solution. If B times the sine of A is smaller than A, okay, so this length, this height is smaller than A, and A is smaller than B, okay, where this is the longest side, we have two different triangles that we could get here. So we have this triangle right here is a perfectly valid triangle where we have this angle B right here is obtuse, or we have the bigger triangle here where angle B would be acute. But A is the same length in either one. So that's two different triangles there. So that's two solutions. Over here on the right, we have A is greater than or equal to B. So the B sine A value is the length of the height. Okay, so that's the value for the height. But A turns out to be bigger than that. And A is also bigger than B. In that case, we get exactly one solution. Over on the right-hand side, if we have an obtuse angle for angle A, this A value right here, if A is not bigger than B, we can't make a triangle. Remember, because this obtuse angle has to be opposite the longest side. So we can't make a triangle if that's the case. And if A is obtuse and the length of A is bigger than the length of B, then we get exactly one solution. So let's put that into practice and see how this works. So we're given a triangle ABC and they give us some information. We have angle A is 118 degrees and side A is 20, side B is 17. Figure out how many solutions there are, solve the triangle. Well, the measure of angle A is bigger than 90, so it's an obtuse angle. And if we compare A and B, A is bigger than B. Okay, so A is bigger than B, we know that one solution exists. So we can use the law of sines to find angle B. Okay, so we can say the sine of A over A equals the sine of B over B. And plugging in the information we know, we don't know angle B. We know the side opposite, little b, is 17. Angle A is 118, side A is 20. Cross multiplying, we get 17 times the sine of 118, and then dividing by 20. And so sine of B is 0.7505. And now we need to use that inverse trig function on your calculator. And so B works out to be 49 degrees. Remember, we're looking for the angle, so keep track of capital and small letters. So now we can use the law of sines to find side C. We can use the sine of C divided by little side c equals the sine of A over A. Now I didn't do this in the video, but side C, if you add 118 and 49 and subtract it from 180, you end up with 13. So this is angle C. So you have to calculate that first. And then cross multiplying, we get 20 times the sine of 13 divided by the sine of 118. And C works out to be about 5.1. Here's an example where A is acute. A is 50 degrees. Its side is 5 and side B is 9. Figure out how many solutions since A is an acute angle. And we want to compare the value of A to that vertical height, B times the sine of A. And it works out that since A is 5, B sine A is 9 times the sine of 50. And that works out to be about 6.9. Well, A is less than that, so A is not long enough, so we're not going to have a solution, right? Since A is less than that, B sine A, and B sine A was the height of the triangle, we can't even make a triangle. Here's another example. We have A, B, and angle A. So again, A is an acute angle. We want to compare B sine A to the length of side A. Well, B times the sine of A, B is 14, angle A is 39. So 14 times the sine of 39 works out to be 8.81. And is A bigger than that? Yes, it is. So this is different than the last slide. A is bigger than B sine A. So therefore, B is greater than A as well. So we know side B is greater than 10. So we know that we have two solutions. Okay, this was down on that lower left side a couple slides ago. So we're going to have two different solutions. Let's take a look at case 1. We have an acute angle B is our first case. The second case will be when we have an obtuse angle B. So first of all, we're going to set up the sine of B over B is equal to the sine of A over A. And multiplying across, we get 10 times the sine of B equals 14 sine 39, dividing by 10, and then using the inverse sine, we get 62 degrees for angle B. Well, now we can find angle C easy enough. Okay, angle C is going to be 180 minus the sum of 62 and 39. And so that works out to be 79 degrees. So now we have all three of our angles. The last piece of information we need is side C. So using the law of sines, we're going to do the sine of C over C, which is 79 degrees, is equal to the sine of, we could use B over B or A over A. I used A over A. And so cross multiplying, we get C is equal to 10 times the sine of 79 divided by the sine of 39, and that works out to be about 15.6. Case number 2 was when we have angle B as an obtuse angle, right here, this angle. Remember the first case we did was when A came down this way and B was an acute angle. So to find out what this angle B is when it's obtuse, it needs to have the same sine value. So you can use the inverse sine, 0.8810, and your calculator will always only give you the acute angle. But what we can do is we can just take 180 minus that, and that'll give us 118 degrees. So that's the obtuse angle with the same sine value, right? So 62 is actually a reference angle for that. So now that we know side B, we can get angle C, right? And angle C is 180 minus the sum of 118 plus 39, so that's 23 degrees. We can use the law of sines to find side C. So we can say the sine of A over A is equal to the sine of C over C. And cross multiplying, we get C times the sine of 39 equals 10 times the sine of 23. So 10 sine 23 divided by sine 39 gives us side C, which is about 6.2. And this is our last slide. I have a check for understanding here for you. Please complete all 4 of these problems and bring them to class tomorrow. We'll see you next time.